Good afternoon, students. So welcome back to the embedded system class. In today's class, I'm going to explain you about the RISC architecture, how the RISC architecture has been designed, and what are the families of ARM processor. Okay, so we are going to see in Unit 2 RISC. The concepts of RISC. What is a RISC stands for? Reduced Instruction Set Computer. So when we are considering the computer set, we may come across a lot of variations of our architectures, right? We had Harvard architecture is there, we'll be having the CISC architecture is there, and the RISC architecture is there. RISC in the sense, reduced instruction set computer. And what we do have a second type of it, CISC. Complex instruction set computer. So basically what is the meaning of this two? So reduced instruction set computers is nothing but the instructions whatever we do have in the computer systems, we try to reduce it so as to get the more number of instructions, more number of operations, not the instructions. Instruction needs to be less and the operation needs to be higher. So in order to achieve this thing, we are proceeding with RISC kind of instructions set computer. CISC is what? Complex instruction set computer. So basically this two, RISC and CISC, is used to design the computer sets, whereas the complex instruction set, what is CISC? I said you, CISC stands for complex instruction set computer. So this is what CISC, right? So what about RISC then? RISC is what? Reduced instruction set computer. So students, so we are going for these two things. One is RISC. What is that? Complex set instruction set computer. And RISC is what? Reduce instruction set computer. So basically where actually RISC and CISC is going to be used, that is our main concept and main consideration of our Unit 2. Unit 2 is completely deals with RISC, right? In RISC we'll be having ARM processors. So what is the RISC actually is all about? So RISC is saying that when you want to design any kind of computer, that needs to have skill users, because as we are reducing the instruction set, that means we are doing some kind of programming which is quite not that much easy as compared to complex instruction set, because here it is going to be get easier to get the performance of it, whereas in reduced instruction set computer it required a skill user to use it, right? So complex design become easier because of availability of large number of instructions. So whereas this is easy, so I can write the first point for it. It is easy for us to easy for understanding for the users, right? Whereas this CISC, what is the CISC is all about? CISC is saying that it is not that much easy. So here the since we are reducing the set computer, so we can write it is a quite complex to understand and required what? It required a skill user to use this kind of set computers, RISC. Whereas CISC, it's quite easy because instruction set is quite complex. It is used so many kind of instruction set. It will be easy for the users to utilize it, and it can be easy for the users to analyze that particular kind of instruction set computers. So the whatever the instructions we are writing for the CISC is what? It is used the large number of instructions. So that's the reason it is used easy for us. It is quite not that much easy because the design is quite complex. Whereas RISC having the fixed instruction cycle and fixed instruction length. So here we are saying as we are reducing, so that's the reason we say fixed instruction cycle and length. Whereas here there is no fix, because since it is using complex, it can be variable. So variable instructions set and instruction length, cycle and length are variable, whereas this used, the CISC used control unit user for producing the implementation of large instructions, means whatever the instructions we are producing, it will be quite larger in the CISC architecture here, whereas in RISC what we are saying? We are saying that since it is using reduced instruction sets, it is quite required as skilled users. It using the fixed instruction cycle and length, and the designing is not that much easy because it is quite complex as we are reducing the sizes of the instructions. The quite opposite for the CISC. So now in RISC we'll be having the ARM processor. So in Unit 2 you're going to learn about how the ARM processor has been used in embedded system. So ARM stands for, ARM has been designed by a organization. So what's the use of it? Why they have designed this kind of ARM processor? So it is been designed by using a von Neumann architecture or Harvard architecture. So because of the importance, what is that importance? ARM stands for Acorn RISC machine. So the full form of ARM is what? Acorn RISC machine, right? What is this Acorn RISC machine is all about? This is nothing but a type of Harvard architecture, or there is one more term we call it as von Neumann architecture. So here whatever the ARM processors we are using, those are considered to be the RISC kind of instructions. So there are different families of ARM instructions, ARM architectures that will be used in the embedded systems. The basic thing what you need to understand is how this RISC and why this RISC kind of architecture has been considered. So there are different points we need to consider. Just I gave a few of it, but the main concept what you need to consider in this is ARM. The main thing why the ARM processor has been designed, it actually used in the VLSI technologies and in the Apple industries, where the Apple mobiles and everything they had, right? There they try to reduce the size, the our compactness. Whatever the embedded system will see, the main concept in embedded system is that the size needs to be very lesser, the weight needs to be lesser, and the performance and the reliability of that particular device needs to be more. The power consumption should be less and the size should be very less. It should be very cost effective. Next thing is what? The performance. The performance needs to be multi performer. Means at a time they can go for all kind of tasks whatever we are going to do it. Since embedded system is going to be get into a specific task. Meaning is that if you use a washing machine, if you use a refrigerator, or you just want to go for any kind of devices which consist of the components of the embedded part, those are going to be used to perform a task which should be cost effective. Second point what it consists is all the parameters whatever the embedded system is going to be get. That means the performance needs to be higher, the implementation would be quite easier, and the timer, counter, there are different parameters. Based upon it we are going for all types of embedded systems. Out of that in Unit 2 you are going to learn about the RISC kind of architectures. In that we will be having the ARM family. In that ARM family you are going to see two things. One is its architecture, the designing of it. As you have know about it, 8085 microprocessor, 8086 microprocessor, 8051 microcontroller, where you have seen the first thing is architecture. Next thing is the approach. How do we get the address bits? Address means what? Addressing mode means what? How and when you can pass the data to it. In that also we are going to see that, and some features of it, ARM families. So those things we are going to see in ARM architectures by considering its data flow model and by considering its design implementation, by looking into the register banks and the internal organization of the ARM architectures with their memories and with their features. So these things we are going to learn in ARM architecture, and the most important thing what you are going to learn is the pipeline concept. So I'll write it down here. So this is the most important feature of ARM processor, that is a pipelining. So there are 3 ways of designing the pipeline, 4 ways, 5 ways, 7 ways, the different types of designing of the pipelines we have, that I'm going to tell you now what is a pipeline. Just a brief introduction of the pipeline, and in detail we will see when we get that concepts. So pipeline in the sense, students, so it is nothing but how we are going to give a data. First we need to give a data to any kind of register or any kind of device or the processor, that is called fetching. First we will fetch, then we go for decode, then we'll try to execute, So this is called the pipeline in embedded system or any kind of processor. So basically fetching means what? Giving the data to the register or giving a data at the particular memory location and the address bit. This is called fetching. After fetching, machine needs to convert into their particular understandable format. That means high level language into the low level language, that is binary forms, so as to understand what kind of instruction the programmer or the user has been given. That is called decode. After getting decode, then the instruction is to get the execution, that is called execute. So this is called as pipelining. So we are going to learn this pipelining in all kind of ARM processor. Clear? So that's it about introduction of that unit 2. So in details we will see, we will get the concepts about the embedded system. Thank you.